Welcome everyone to today's discussion on polynomials. Let's start with the basics. So what exactly is a polynomial? A polynomial is made up of two terms, namely poly meaning many and nominal meaning terms. A polynomial is defined as an expression which is composed of variables, constants, and exponents that are combined using mathematical operations such as addition, subtraction, multiplication, and division. Based on the number of terms present in the expression, it is classified as monomial, binomial, and trinomial. In a polynomial, we have constants, variables, and exponents. In our example, 3x squared plus 5x minus 2, our constants here are the numbers 3, 5, and 2, which are all whole numbers. Our variable is the letter x in 3x squared and 5x, and our exponent is in the term 3x squared, which is the number 2. The degree of a polynomial is defined as the highest exponent of a monomial within a polynomial. Thus, a polynomial equation having one variable which is the largest exponent is called a degree of the polynomial. Here, we have our polynomial and their degrees. A zero polynomial's degree is not defined. A constant polynomial degree is zero since there is no variable, just a whole number. In a linear polynomial, the highest exponent is 1. In a quadratic polynomial, the highest exponent is 2, which is shown here in our term 4x squared plus 1x plus 1. In a cubic polynomial, the highest exponent is 3 in the term 6x cubed. In a quartic polynomial, the highest exponent is 4, here in our example in the term 6x raised to the 4th power. The terms of polynomials are the parts of expression that are generally separated by a positive or negative sign. So each part of a polynomial in an expression is a term. Here, in our polynomial x cubed minus 2x squared plus 3x plus 4, the terms are x cubed, negative 2x squared, 3x, and 4. And our degree is 3 since our highest exponent is here in our first term, x cubed. Depending upon the number of terms, polynomials are divided into the following categories. So the different types of polynomials are monomial, binomial, trinomial, polynomial containing 4 terms, which is a quadrinomial, and a polynomial containing 5 terms is a pentanomial. A monomial is an expression which contains only one term. For an expression to be a monomial, the single term should be a non-zero term. A few examples of monomials are 5x, 3, 6a raised to the 4th, and negative 3xy. Next is a binomial. A binomial is a polynomial expression which contains exactly two terms. A binomial can be considered as a sum or difference between two or more monomials. A few examples of binomials are negative 5x plus 3, 6a raised to the 4th plus 17x, xy squared plus xy. A trinomial is an expression which is composed of exactly 3 terms. A few examples of trinomial expressions are negative 8a raised to the 4th plus 2x plus 7 and 4x squared plus 9x plus 7. So there are 4 main polynomial operations, which are addition of polynomials, subtraction of polynomials, multiplication of polynomials, and division of polynomials. But we'll be focusing on solving polynomials. So any polynomial can be easily solved using basic algebra and factorization concepts. While solving the polynomial equation, the first step is to set the right-hand side as 0. The explanation of a polynomial solution is explained in two different ways: solving linear polynomials and solving quadratic polynomials. So we'll first do solving linear polynomials. Getting the solution of linear polynomials is easy and simple. First, we isolate the variable term and make the equation as equal to 0, then solve as basic algebra operation. Here in our example, we solve 3x minus 9. First, we make the equations as 0. So 3x minus 9 is equals to 0. Which is also 3x is equals to 9, which is x is equals to 9 over 3. Or x is equals to 3. Thus, the solution of 3x minus 9 is x is equals to 3. Next is we solve for the quadratic polynomials. To solve a quadratic polynomial, first we rewrite the expression in the descending order of degree, then equate the equation and perform polynomial factorization to get the solution of the equation. An example to find the solution of a quadratic polynomial is given here. We solve for 3x squared minus 6x plus x cubed minus 18. So first, we arrange the polynomial in descending order of degree and equate to 0. So x cubed plus 3x squared minus 6x minus 18 is equal to 0. Now we take the common terms. X squared is x squared, open close parenthesis, x plus 3 minus 6, open close parenthesis, x plus 3. Or x squared minus 6, open close parenthesis, and x plus 3, open close parenthesis. So the solutions will be x is equals to negative 3 or x squared is equals to 6. Or x is equals to plus or minus the square root of 6. So that would be all. Thank you for joining today's discussion on polynomials. We've explored their definition, classifications, and how to solve them using algebraic techniques. Understanding polynomials is essential as they form the foundation of many mathematical concepts and real-world applications. I hope this session has given you a clearer perspective on how polynomials work and how to approach solving them. Keep practicing and you'll find that polynomials are not just theoretical expressions, but powerful tools in problem solving. So keep exploring, keep learning, and see you all next time. Bye!